I work as a system and network engineer at Yakaz. For the moment, I'm the only one that follow your guidelines. Almost. I am an early fan of Varnish, and I use it in production since 2007, when I was head of hosting for a French company. Varnish saved my ass a couple of times, like the Marines wrote to Palinic camp. We chose it in 2007 to replace our Squid instance that were acting as reverse proxy. I work for Yakaz, and when I began my job 2 years ago, they use other cache technology, or no cache at all. We start using Varnish to serve static content like GS or images. Then we replace a homemade LAMP platform that was used as middleware cache. What is Yakaz? Perhaps you don't know us. We are a social platform that creates links in a neighborhood. We are persuaded for 3 years that internet can be a major actor of the local arena. I will show you some screenshots of what our website look. So here's the home for the UK. Very nice. You see that we have Facebook Connect and Google Connect too. This is a typical home page. You see that we have our own mini-map that is realized using OpenStreetMap. Everything on our website is geolocalized, so we try to determine it the more approximately where you are and give you a result of your search for the place you are. So here we are on the map. The map is a map of the area, and I want to notice that I give French lessons too. If you see, I give French lessons to ladies, 18s. It's a true snapshot that I take 2 days ago. Everything is done in a user approach. We have learned from our search and ads engine history that users should find what they're looking for. Everything is done to achieve this goal. When we render a page or when we create a result page to answer on a user request, we split the content in 3 categories. Critical up-to-date is the first one. Typically, this designs a result list. Those results are mandatory. They are computed immediately or have been taken in a really fresh area of cache. Just to remember, this is this part, the center of the body. The second type, we call the second category critical content. Those content are optional, even returning no. We don't need an absolute freshness. Typically, the photo are a good example of this category. The third category is called not critical content. Those content are optional. Even returning no result is acceptable for us. This category is used for cosmetic content in a page, like hot topics or mosaic. Typically, the mosaic is the 2 things you see under the minimap. Some word of technical context. We use Debian everywhere for stability and historical reason. Our website is really dynamic. You will have different pages depending on your language, which is auto-detected, your location, you are connected or not. In this special case, we will do our best to produce accurate content with what we know about you. We use Exalid, and we have 100 million of elements in our search indexes. Every content that could be searched is present in our indexes. When you leave an ad or a question on Yakaz, in 2 seconds, in less than 2 seconds, the content is available. It's fully available. Because we use live update, and every new content is immediately searchable. We only keep the data for 3 months, which means that after 3 months, we forget every content, questions, ads, or advice. The user can maintain his content, but we ask him if he wants that we do so. We do that for 2 reasons. First, the type of content we store could have a short validity or duration. And second, more ethically, we think that Oblivion is part of liberty. We use Cassandra as a data store. We put in it image, user accounts, and logical connections between users. In front of Cassandra, we use Varnish. We also have a great deployment system that we use Foreman and Puppet to manage everything in our website. Search index, Cassandra, Varnish, of course, and all the things we name. We use two types of Varnish server. First, we use Varnish as a standard reverse proxy cache. The values you see is for one dedicated server with 32 gigabytes of RAM. We have 3 servers of this kind in France. The load balance technique is DNS and keep alive. And the backends are essentially Cassandra. This is the first kind. The second kind is middleware cache. We have 5 servers like this one, this with 200 gigabytes of RAM, but only 60 are used today. The backends are mainly Exalid and Cassandra. Notice that we don't use Varnish in front, mainly because the only way to configure it nicely is by using hsides include, and it's a big word for us. The way our website is present on the web is really distributed. So when a user reaches us, he can come everywhere with every language. We spent a month recently to try to put Varnish in front. And the best way for us is to keep it as a middleware, even if we lose some time doing this. So I will present 4 tricks that we use on a Varnish instance. First is the way we found to optimize our hit ratio and the number of elements in our cache. The second is le perroquet, a way to fill your cache without eating backends. Third, I will show you how we slightly divert the use of the Varnish grace. And fourth, the technique we use to be always fast on not critical contents. On our standard reverse proxy, we only serve static contents like JS or JavaScript or photos. We have a lot of photos and we have a lot of ads, but as usual, the ones who are written are almost always the same. We have home effects. Some content are in good place during a short time, and they are eaten more often. If those content match the trends, they will be eaten longer. We have calculated some statistic about the probability to be eaten once, twice, and during a period of 1, 2, 3 days or a week. This analysis gave to us that it was interesting for us to keep those best content in cache, because another hit to the backend will refill the cache with exactly the same content. So we choose to renew the TTL of those objects based on a timing condition. On this cache, we divided the average TTL by 2. The number of objects decreased by 2 and was divided by 2 too, and the hit ratio was enhanced. So the idea is the following. Renew the object before the end of the TTL. The hours, the timing, here we see if the object was last used 10 hours ago, and if we are 5 hours to the end of the time of the validity in the cache, then we renew the TTL for one day. And for us, it works quite well. The second tricks is the perroquet. Le perroquet means parrot in French. We got a dummy HTTP service with Pion Network Library, which is a C++ framework for building lightweight HTTP interfaces. Our perroquet is returning the content of the forced content HTTP headers. This gave to us two new features. A way to prefill the cache. In some case, we don't want to load the backend with content that we already know. And the second is now Varnish acts as a nice HTTP key value store. The key is the address, and the value is the content of the HTTP for HTTP header. It's very useful for us because we were looking for such a service, and when it works, it's really stable and fast. So it's a little scheme. Yeah, just you have the address with the first request is in black and the second is in red. We design if there is a third request, or if you replace the first request with foo as false content, the next time the false content will be foo. We replace it too. There is a way to do it by the hand. And here's the code. We use a marker during the receive to ensure that we will purge correctly the content in the hit. I hope that in the next, my colleagues are hoping that a day the backend like Perroquet will be built in Varnish, because for us it has giving the ability to prefill the content of the cache with a simple HTTP call could be interesting. Our internal rules are the following. We first need to be stable. The second, we need to be fast. And the third, we try to embed the content for the users. So how to be fast and faster? In our use case, there is no race possible between backends and cache. A request to a search index could take up to 3 seconds. So for us, the first entry in the cache is always long. But after it's fast, our idea was to consider how we can gain speed by using appropriate TTL. Tempus semper fugit, and we look at the value of a content in cache with time access. We found two of our content mentioned earlier, critical up to date and critical. Following this idea, in case of critical content, we force Varnish to look up in grace even if the backend are healthy. So for critical content, we consider that every object stored in Varnish is enough good for us. Here is how we proceed. If we have the first request is in black, so there is a miss, we go to fetch on the backend. Our search index are answering in between 100 milliseconds and 3 seconds. And the part of the request took 2 milliseconds. So if the first request will be done like this. The second will be hit cache in red, and in gray, and after the TTL, the result will be done in gray. So we gain time between TTL and grace. The same object could be called with force cache or without force cache. So there is a dynamic, because if we can have a force cache query very fast, and the next time when we really need an up-to-date content, the object will be purged and will be available. But this time we have the time to wait. We are in a case that we don't want to wait, or we want to wait the less. So to achieve this behavior, we declare a backend dead, which is by naming convention definitely sick. When we want to force the grace, we add extra HTTP header force content, force grace that triggers the use of this backend. And here is the VCL code. So if there is no results, we go to error, and then we restart, and then we have a result. The last trick we use is delayed fetch. For the moment, I have no solution for our not critical content. Here it is. We wanted a way to be sure that we have an answer in 2 milliseconds. An answer or not, with content or not. We don't want to wait for this kind of content, because they are not definitely they are not mandatory for the user experience. So the behavior is the following. If the content is present, give it. If there is no content, return immediately an error, but launch a background job that will fill the cache for the next time. The query was done once. Perhaps it is not stupid, and the next time we want to answer this request. In both cases, we know the duration of this request will be roughly 2 milliseconds. You see the two types of requests. The first, this is a miss in blue. So the request is done. We answer 407. And but the backend in background is hit, and the cache is filled. And next time we are in the perfect situation, because the object is in cache. To achieve this, we first use inline C and focus thread that makes a good HTTP call. It works, but no more than a month. We also try a log watcher that replays the request found in the log, but we use huge addresses, and it didn't work well. So with the suggestions of the Varnish software team, we try vmod curl with ridiculous timeout. And it works fine. Here is the code. So it's important to use hash in your busy, because we notice that when we later do the curl call, there is a race condition between the request itself and the background request. So if this is a miss, we launch a curl fetch for the same URL locally on the same. Our Varnish server are running on a port on a 80 port. So we replace the requests immediately on the same varnished instance, but with a timeout of 1 millisecond. So we don't wait for the result. we know that those results will take more than 100 milliseconds to the backend to be served. So this is a miss, but this one will be a hit because there is no they won't have the delayed fetch header contents. So next time we will come, we will have the content. And here you see, if we are in the grace period, because so typically we are in the fourth grace case. If we are in the fourth grace period, we renew it, but we serve the stale content. So this is when we use false cache and delayed fetch query. So we know that every request done using those two special headers will take 2 milliseconds. And when we build a page for this type of content is very useful. One thing is that with appropriate TTL and grace period, the object will always stay in cache. If they don't stay in cache for us, it doesn't matter, because if they are not hit in cache, that means that nobody have interest in those objects. So there is no reason that they stay in cache. So thank you for your attention. And if you have some questions. Thank you. Oh.
Hello. So if I got this right, you're solving the problem of having of wanting to present something to the user where nothing is better than them waiting, but filling the cache for the next request that comes in.
Yeah.
Is that.
Yeah.
Does that not? Is that not pushing the problem into the Varnish layer, where it should be sitting at the application level, with the application making requests, with timeouts enforced at the application level, and then knowing how to represent, I didn't get any response back to the user. I'm just coming from it from the perspective of I like solving problems in systems level things like Varnish, like Nginx, but
it could be right, but in our use case, we have the requests we have are really distributed, and we want to have a rich service. So to provide the most interesting result content for our user, but also to enhance their experience with other content. And for it's too distributed to have a search index that could respond in 3 milliseconds. Not everyone is Google. You cannot. There are limitations in using search index, and those limitations at the time when you have a great number of objects, you cannot be fast. We try to render our page behind 100 milliseconds. We want to have the page built behind 100 milliseconds. When you have 5 or 6 requests that cannot be parallelized for the result of your page, you cannot go. You cannot be fast without caching. And one other thing is we try to always answer to our users. So if you ask for a car in central London, and there is no result on Yakaz for a car in central London, which is probably false, but it will extend to greater London, and then it will extend to say he will have a look and then try to extrapolate, try to go he will try to give you an answer. What is the nearest car? What is the nearest car you can find near you?
Do you have any stats on how often you'll do that backfill of the cache and it's never actually used again?
No, not for this. Thank you.